The competition between major rocket companies is getting intense. SpaceX is currently leading the pack in the rocket industry, but surprisingly, Blue Origin is making a comeback after being quiet for quite some time. Jeff Bezos, known for making big promises without much to show, seems more confident now. That's because things are about to change by the end of September this year. Blue Origin's New Glenn rocket is gearing up for its first flight, and preparations are moving faster than expected. We'll dive into all of this and more in today's episode. As we near the end of 2023, excitement is building among space enthusiasts. This time of year is perfect for space companies to wrap up their unfinished business. So, what's on the horizon for September? It's a big month for U.S. space giants with several major launches on the schedule. EULA's Vulcan rocket is set for its second certification mission. SpaceX is gearing up for its fifth test flight of Starship, and perhaps the most anticipated event is the debut launch of Blue Origin's New Glenn rocket at the end of September. This marks the first orbital rocket from Blue Origin, a company that has been competing fiercely with SpaceX for the past 2 decades. It might seem surprising to some, and perhaps even like a real-life tortoise and hare story, but Blue Origin is finally nearing its first big milestone. Now it looks like the tortoise is picking up speed. This momentum is highlighted by a recent interview between Jeff Bezos and the popular space YouTuber, Everyday Astronaut. In the interview, Blue Origin aims to demonstrate just how ready they are for New Glenn's first orbital flight. This is a significant media move and a new milestone for Bezos, especially considering the criticism he and Blue Origin have faced over the years. Finally, he can proudly present an orbital rocket. With a tentative launch date of September 29th, New Glenn is nearing readiness from a manufacturing perspective, although the rocket isn't fully assembled yet. So far, we've only seen a mock-up of New Glenn's first stage at Cape Canaveral, and a fully completed rocket hasn't made an appearance. Nevertheless, Blue Origin needs to be ready for its debut mission. This mission, named Escapade by NASA, is set for Mars, and 2 small spacecraft have already arrived in Florida to prepare for the upcoming launch. To keep up with this timeline, Blue Origin has been busy conducting test flights on various rocket modules over the past few months. Before diving into those tests, let's first look at the structure of the New Glenn rocket. It's a 2-stage orbital rocket, with each stage made up of smaller modules, including aft, mid, and forward sections. Starting with the first stage of the rocket, the forward module sits at the top of the booster. In the interview with Bezos, he explains how the fabric covering you see is actually thermal insulation, which Blue Origin developed. It's highly reusable and has already been tested on the New Shepard rocket. The mid-module is where the fuel and oxidizer tanks are located, made from durable aluminum to withstand the intense G-forces during re-entry. The real power of the first stage comes from the aft module, which houses 7 B-4 engines. These engines are notable for their ability to restart and provide precise thrust vector control, meaning they can adjust the rocket's direction accurately, and they also have deep throttle capabilities for controlled power output. Bezos also detailed the engine setup, mentioning that the rocket has 3 engines that can gimbal or pivot and 4 that are fixed. During the return, the 3 gimbaling engines fire up to slow down the rocket, and then the final landing is done using just 1 engine. The aft module also includes 6 deployable landing legs, crucial for landing the first stage on a drone ship in the Atlantic. Bezos explained that these landing legs start deploying 14 seconds before landing, take 8 seconds to fully extend, and their deployment is aided by gravity due to the rocket's deceleration. Moving to the forward module of the first stage, it includes 4 actuated aerodynamic control fins, which help manage the rocket's orientation during its descent back to Earth. This section also houses the connections for the ground support systems known as umbilicals and serves as the link to the second stage. Inside, you'll find important avionics, including an autonomous flight safety system, which helps keep the rocket on track throughout its mission. Now, looking at the second stage, it features an expendable liquid hydrogen fuel tank and is powered by 2 B-3U engines. These engines can pivot or gimbal, allowing for precise adjustments in space. Combined, they generate a powerful 1,600 Newton, about 240,000 pounds of thrust in a vacuum. The second stage measures 7 meters 23 feet in diameter and 16.1 meters 52.9 feet in length, extending to 23.4 meters when including the 2 high expansion ratio nozzles. One of the standout features of the New Glenn design is the pneumatic pusher stage separation system located in the forward module. This system ensures a clean and reliable separation between stages before the second stage engines ignite, contributing to the overall reliability and success of the launch. In recent months, Blue Origin has been rigorously testing various components of its New Glenn rocket at Launch Complex 36 LC-36 to ensure everything is ready for the rocket's highly anticipated maiden flight. These tests are crucial for gathering essential data and validating the design and functionality of the rocket's systems. In early July, Blue Origin focused on recovery tests for the New Glenn Transporter Erector T system. This system is responsible for moving the rocket from a horizontal to a vertical position and supporting it during launch preparations. The tests at LC-36 involved pulling the large T away from the rocket and successfully disconnecting the umbilical connections from both the first and second stages. After completing these tests, Blue Origin lowered the T and mock-up stages back to the horizontal position and returned them to the hangar for further analysis. During the same period, a New Glenn first stage aft module was observed at the test area, about 150 meters from the launch pad. This aft module, which houses the rocket's engines and landing legs, underwent specific tests to evaluate the performance of its 6 deployable landing legs. These legs are critical for the rocket's ability to land back on Earth after launch. Blue Origin's CEO Dave Limp confirmed that this aft module is actual flight hardware, indicating the company's serious intent to attempt a first-stage landing on New Glenn's debut flight. On July 25, Blue Origin moved the forward module of New Glenn towards Launch Complex 36 LC-36. The company's CEO, Dave Limp, shared an update on X, announcing that the module had successfully completed its validation tests. These tests included activating the reaction control system, which is essential for maneuvering the booster in zero gravity and during landing. The forward module also houses 4 large aerodynamic fins that help guide the booster during descent. These systems are crucial for making New Glenn's first stage reusable, a key feature of Blue Origin's design. By August 8, Blue Origin made further progress, as the second stage of New Glenn was spotted outside the company's factory at Exploration Park. This stage was also transported to LC-36 for testing. Dave Limp confirmed that this second stage is flight-ready hardware, set to be used in New Glenn's maiden mission. Once the testing phase is complete, this stage will be integrated with the first stage, which is expected to arrive at LC-36 soon. Now, can Blue Origin really catch up with SpaceX? It's a tough comparison. While both companies began working on their next-generation rockets in the early 2010s, their approaches have diverged significantly over the years. SpaceX has rapidly advanced its Starship program, with numerous prototypes and test flights. In contrast, Blue Origin has moved at a slower pace with New Glenn, which shares some similarities with Starship, such as its size and methane oxygen engines. However, Blue Origin's more cautious development strategy has led to a noticeable gap between the two companies in terms of progress and innovation. Many industry observers liken this competition to a matchup between the New York Yankees and a Little League team. There's a clear difference in scale and success, with SpaceX currently dominating the race. SpaceX went through several major redesigns of its next-gen rocket before eventually discarding most of that earlier work. By late 2018, Elon Musk introduced a new approach, a stainless steel rocket called Starship. This decision marked a significant shift for the company. SpaceX quickly began developing steel prototypes and, less than a year later, successfully flew a test vehicle known as the Pathfinder, which used an early version of the Raptor engine designed for Starship. The company then set up a makeshift factory using tents and began producing and testing numerous refined prototypes. Between August 2020 and May 2021, SpaceX conducted flight tests on 7 of these prototypes. One of the key milestones came when a full-size steel Starship prototype successfully landed after reaching an altitude of 10 kilometers. The company then set up a makeshift factory using tents and began producing and testing numerous refined prototypes. Between August 2020 and May 2021, SpaceX conducted flight tests on 7 of these prototypes. One of the key milestones came when a full-size steel Starship prototype successfully landed after reaching an altitude of 10 kilometers. After this achievement, the pace of testing slowed down considerably. However, in 2023, SpaceX managed to complete its first 2 orbital test flights, marking a significant step forward in its ambitious Starship program, before eventually discarding most of that earlier work. By late 2018, Elon Musk introduced a new approach, a stainless steel rocket called Starship. This decision marked a significant shift for the company. SpaceX quickly began developing steel prototypes and, less than a year later, successfully flew a test vehicle known as the Pathfinder, which used an early version of the Raptor engine designed for Starship. New Glenn, which measures 7 meters in diameter and 98.8 meters in height, compared to Starship's 9 meters wide and 121 meters tall, will utilize traditional aluminum alloys for most of its structure. It will be powered by 7 B4 engines, feature deployable landing legs, and have an expendable upper stage with 2 B3U engines. The rocket will also be topped with a large composite payload fairing. In summary, while Bezos may prefer a slow and steady approach for Blue Origin, akin to the tortoise in the fable, SpaceX has been pushing forward relentlessly without pause. That's it for today's episode. Thanks for watching, and we hope to see you back here next time.